Okay, this question is from matrix, and we have two sets of linear simultaneous equations that we need to solve to find the values of x and y respectively using matrix determinants. All right, using matrix determinants. That's what we're going to use. So solve the simultaneous linear equations using matrix determinants to find the values of x and y, of course, respectively. So when you see something like this, what comes to your mind? Very simple. What you need to do is, first of all, we put down our solution, right? And then find the determinant. The first thing to do is to find determinants. So we will now say, let the determinants, okay, determinants, that represent this, okay? We need to do this. So under our solution, we have determinant is giving us that is equals to bring out the coefficients of the individual variables we have. Coefficients of y, x, and y, and that constant, those constants, right? So let's do this. First of all, the first column is going to be 2 and 1. 2 and 1. Second column here is 3 minus 5. 3 and minus 5. This forms the general determinants, right? Okay, so with that, we can find this. We cannot say that to find this we have bracket open 2 times minus 5, okay? Minus bracket open 3 times 1. Let's see what happens at that point. And we have 2 times minus 5 is minus 10, right? Minus 3 times 1, this is 1. 3 times 1 is simply 3, right? And we have this. This means that we have, this is equal to minus 13, all right? Minus 13. Let me write this well. Minus 13, okay, minus 13. Therefore, our determinants by this letter is minus 13. So we keep it, we keep this. We have now successfully found the determinants to be minus 13. This is minus, all right? So what do we do next? We are going to simplify further and classify this as determinant 1. This general determinant, we can use T, okay, total determinants, right? But we need to find determinant 1 represented by, okay, we can say determinant 1, look at this, that 1 represented by delta 1. We can also find that 2, right? That 2, okay, represented by delta 2. So let's find the determinant 1, okay? How do we find that? How do we get that? But before, let's go back to this. We can have the constant. The constant is 12 minus 7, right? The constants are 12 and minus 7. That is 12 and minus 7. Let's see. So for us to find determinant 1, we're going to use the constants. Use the constants to represent or to replace. Use the constants to replace the first column. So let's go. The constant is going to replace the first column while we retain the second column. So constant is going to be 12 and minus 7, the first column here, right? Look at the first column here, has been replaced with the constant 12 and minus 7 here. And then we retain 3 and minus 5, okay? We retain 3 and minus 5. So we have 3 and minus 5. This forms our determinant 1. Because why are we using determinant 1? Is equal to x. Is equal to x. Because we want to find the value of x. So we do that. Determinant 1, we find it this way. Bracket open, 12 times 5. 12 times minus 5. Bracket close minus. Let me take chalk. Alright? Then we open bracket again. Becomes 3 times minus 7. 3 times minus 7 bracket close. So let's go. We are still finding determinant 1, which is given 12 times this is minus 60. Alright? And this is 3 times this minus 21. This will change this to plus 21. Alright? So if we have this, what happens next? What happens next? I think here we will not have the determinant 1 is equals to minus 39. Yes. Let's cross check if we are going to get that. 39 plus 21, will it give us 60? This is 0, 10, we write 0, carry 1 here, 4 plus 2, 60. So it's correct. Okay? That's correct. It's been confirmed. What this means is that determinant 1 is equal to 39. We keep it. We keep it. Very good. Quite interesting. At least we can now find the value of x. How do we find the value of x? The value of x now becomes x is equal to determinant 1 all over total determinant. Okay? And determinant 1 is minus 39. Total determinant is minus 13. Good. Determinant 1 is this. Total determinant is minus 13. So let's cancel wisely. Minus cancel minus. 13 cancel itself 1. 13 divided 39, we have 3. Therefore, the value of x at this point is equal to 3. Solved. Solved. Good. Now, let's go on. We are not done yet. We've not finished. The next thing to find is the value of y in this set of linear simultaneous matrix equation. Alright? So let's find y. Without wasting time, we clean this. Alright, we return this, sorry. Let's return this because we need to pivot on this, yes. And this is 12, and this is minus 7. Okay, so we clean this. We have found the total determinant to be minus 13. Alright, total determinant is always minus 13. So we are not making mistake about this. Alright? So let's look at how we can find the value of y. Okay? And for us to find the value of y, we need to determine determinant 2, which is given as, look at this. Determinant 2, our concern is this. Okay? Our concern is this. Because that is what we are going to do. We have found determinant 1. Determinant 2 is this. So what do? We now return 2 and 1 and replace column 2 using the constants, which is 12 and minus 7. Alright? That's it. Look at it very well. The first time we replace the first column with the constants, but this time around we are replacing the second column with the constants while we retain the second column as it is. Now we've done that. Quickly, we can then find determinant 2 is equal to, bracket open here, 2 times this, 2 times minus 7, bracket close, minus, bracket open once again, alright? And then 12 times 1, 12 times 1, bracket close. And what do we have at this point? We have determinant 2, this time this is minus 14. And finally this time this is minus 12. Good. When we do the normal thing here, we have minus 14 minus 12 is going to give us minus 28. Yes. This B is going to give us minus 28. So, determinant 2 has been found. Determinant 2 has been found. What's wrong with my chalk? There's nothing wrong with my job. Come on. So have determinant 2 is minus 28. Okay. Okay. So let's see. I hope we're not making any mistake. Hold on. Hold on. We retain this. Okay. 2 and 1. Yes. We retain this because this 2 and 1. I want to cross check to make sure there's no mistake at this point. Yes. But we replace this with 12 and minus 7. And that is 12 and minus 7. That is this. So let's check 2, okay, times minus 7. That's this, minus 14. And then 12 times 1. And that's this. Okay, we don't have anything there, right? Okay, 2 times 7 is 14, minus 14. And then 12 times 1 is 12. By this minus, we have this. And this will give us minus 28. Good. If that is the case, if we have successfully done that, it means we... not minus 28, yes. Yeah. I would have made a mistake. This is minus 26. What was I thinking? Minus 26. Good. So this is minus 26. Minus 26. Corrected, please. Not minus 28, yes. 4 and 2 is 6. Good. Don't mind me. Okay? Now we found determinant 2. The next thing we are going to do is to find the value of y, because determinant 2 represents the value of y. So let's go. Let's do that right away. I don't want to clean greater part of the board because we need it. Alright, to find the value of y, we have y is equal to determinant 2 all over determinant total determinant, okay? And that is, for determinant 2 is minus 26, for total determinant is minus 13, okay? If we cancel wisely this, we take care of this is 1, and then this is completely 2, all right? And this is equal to 2. Therefore, the value of y is equal to 2. Solved. That is the value of y. So we have successfully found the value of x to be 3 and value of y to be 2, respectively. That's solved. We've solved this set of simultaneous matrix equation has been solved using determinant method. Solved. But if you have any issue with the steps, don't forget, put it in the comment section. I want to see your reactions. I want to read your comments. Give me some thumbs up. If you have found value in this, subscribe and give me some thumbs up, all right? I sign out at this moment. See you in my next class.